Hello students and welcome to the Inequalities Unit 7 and Lesson 3B, Part 1. I have broken up this one into two parts just to give us a little chance to work specifically with these other methods. So just to recap, Lesson 3A, Part 1 and 2 dealt with Method 1 and 2 on how to solve quadratic inequality. So our first method was to solve it by graphing using Xavier method, or if it was in vertex form, to use the vertex to sketch the graph and find the shaded area. And if there's two variables where the quadratic is with respect to y, the solution is anywhere in the shaded area. And then the second part of lesson 3A, the solution was the quadratic was with respect to 0, not y. So there was only one variable, and the solution therefore only existed on the x-axis, where y is 0. And we looked at the root and test point method of solving those quadratic inequalities. I'll be honest, for the most part in my life, I use the roots and test points method to solve quadratics. However, there are two other methods that we're going to go over. One is case analysis and the other is sign analysis. And you would use these methods if, first of all, they just work better for you. If it makes sense more for you and your brain, then you use the method that works the best for you. The other reason that you would use case analysis or sign analysis is if you have a whole lot of different factors. So not just for quadratics, but when you have more complex inequalities and more complex roots. So it's not so simple as just plugging in a really easy 0 and getting a really fast calculation. It's actually quite a process to find out if the statement is true or not. You might want to use this method instead, because you don't actually have to find out after you find the roots. You don't have to find the values, do any calculations so much as understand what is a positive, what is a negative. Okay, so I'm going to use the exact same inequality that I've used for the other two just to show you what it is. But again, you probably would use roots and test point method for this particular inequality, but I'm going to keep using this one for the other methods just to show you how we get the same answer with just different methods. All right, so the first thing you are always going to do is you are going to factor. Okay, so we're going to factor this, and hopefully by now, the third time doing the exact same quadratic, we're getting quite comfortable with this being x minus 3, x plus 1 is less than or equal to 0. Okay, so I want to refresh your memory that less than 0, we're not really worrying about the equals part here. It's the inequality part that we're having to deal with. Less than 0 means what? That means it's negative. Okay. That means it's negative. That means there's two possibilities. I can't fit possibilities in there. There's two possibilities, okay? So it's either, I'm gonna move my head more out of the way in that screen there. It's either the first factor is negative and the second one is positive, or the first one is positive and the second one is negative. So what I mean by that is either you have to get a negative value when you have two factors, you have to have different signs. So one has to be positive and one has to be negative. But of course, there's two possibilities for that. My writing in this board is just really on a roll lately. So I'm going to try saying that one more time. So you can either have the first factor negative and the second factor positive. That will overall give you a negative value. Or the first factor can be positive and the second factor could be negative, and that will also give you a negative value, right? They can't both be positive and they can't both be negative, because a positive times a positive is a positive and a negative times a negative is a positive. So we're going to look at both cases. So we're going to look at the first case where the first factor is negative and the second factor is positive. So the way I've written them out, this is the first factor here, and this is the second factor here. I just realized I forgot my sign, x plus 1. I swear doing this on a recording just makes everything just makes everything more complex. If I could pause and easily edit, I probably would, but my computer cannot handle that without crashing. So we're just doing some real time here. All right, so it is +1 here, okay? So if I'm looking at the first one being negative and the second one being positive, that means that this first one has to do with 3. Okay. So if I'm saying that x minus 3 is less than or equal to 0, that means x has to be less than or equal to 3, right? So if I were to put that on a number line, I would be saying case 1, this would be how we would represent that one being negative. And if I look at the second factor is x plus 1, and we're saying, well, if the first one is negative, x plus 1 has to be more than 0, has to be positive. So that means that x has to be more than or equal to -1. So subtracting 1 from both sides. So that means it has to be in here. Is there a region that satisfies both these cases, right? And the answer is yes. This region right here is where x is between those two values. So it's possible to satisfy those two things where x can be, the first factor can be negative, the second factor can be positive, and overall will give you that overall negative less than or equal to 0. Okay, so that would be a solution. That is our solution. That is the answer. But let's show what happens if we did the other case. So remember, the other case was when the first factor is positive and the second factor is negative. So if we said x minus 3 has to be more than or equal to 0, that means we would have shaded this area. And if the second factor, which was x plus 1, has to be negative, that means it's less than or equal to 0. That means that x has to be less than or equal to -1. Do we have any overlapping of those two where they can both be, where the first factor can be positive and the second factor can be negative? Do we have any values that have any overlapping of those two areas I drew? And of course, no, we don't. So that isn't the solution. So case 1 is the solution where the first one is negative, the second one is positive, and the values that will give us these cases where it'll make the first factor negative and the second factor positive is when you pick values of x where x is between or equal to -1 and +3. So that is case analysis. And how we would state this answer is, again, I just kind of want to go over the condensed way of stating this answer so that it could be equal to -1. So we use a square bracket, comma, 3, and of course it can also be equal to 3, and it's in between those two. So that is how we would state our answer. What I would like you to do now is do page 484, number 6, and let me know how that goes.